Welcome back. After learning how to clean data using OpenRefine, we are back to working with data in R. This week, we'll learn about a package in R called dplyr that makes it easy to work with tabular data. We're continuing to work with data from the portal project, and you'll need to download the 3 files from our Canvas page into a data folder. So let me get set up. I've got our studio session open. I want to create a new project for this week, and I'll call this Working with Data. I'll create, and then I'll open up a new R script. This should start feeling familiar. And I'm also going to create a new folder inside my project called data_raw. And I forgot to save the R script, and I usually call it the same thing as my project, unless you want to get a little more creative. So the first thing we need to do is download the data. You can do this directly using the links and save as, but I like to do everything in the same place. So I'm going to create an object called surveys, and inside that object I'm going to store the result of this download using read.csv, and I've copied the first link for surveys, and I'm going to paste it in here. Read.csv, and strings as factors is set as false by default, and so I can run that. I've downloaded the data into my R session, but I want to get it into the data folder. And so to do that, I would need to use a second line to tell our write.csv surveys, and I want to call it surveys.csv. And now it wrote, but it didn't write into the folder that I wanted it to because I left that out. So I'll write that again. And I get an error message because that directory doesn't exist because it's actually called data raw. All right, I've gotten all my error messages out for the day, hopefully. You might decide to do a more direct way, which would be to go onto our canvas, right click, save link as, and then save it directly to the folder. So now I have it saved. So it takes 2 lines to do that, and you'd want to do that for each of the file. So I'm going to do that for the species and the plot data. And I'm going to copy and paste those links so I don't have to type. Oops. And I noticed that there's this error message that comes up because I forgot those apostrophes. For the sake of time, I'll keep these in my environment instead of saving them into the data folder. But to do that, I would copy and paste these 3 here and then change this to species. And see how I'm eliminating as much typing as possible. So I might clean that up a little bit. Download data. All right. Now we want to install and load our dplyr package. If you've never installed dplyr before, you will need to use the install.packages function. Because I've already done that, I'm not going to run this line. And You only have to install a package once. Then when you open up R in the future to call that package, you would use the library function. Now we can look at these objects, plots, species, and surveys. And if you notice, each object or table contains one type of data per table. So plots has information on plot type, and it has this column called plot ID. Species has only information about the species, names, taxon, species ID, and then surveys has all the individual observations, but it also has the same column headers, plot ID and species ID, which relates surveys to the species and plots tables. This is a great example of keeping data tidy and separate in individual tables. And then you can merge them together when you need information from another table. What's great about dplyr, let's look at some of the basic dplyr functions. One of the first ones is the select function. And if I hovered let's see if I can bring up that yellow text box again. There it is, select. So the first argument of this select function is the data. So let's say we want to look at our surveys data frame, and we want to select additional columns. So the first argument is the data, and any subsequent arguments are the columns that you're interested in selecting. R recognizes these as columns. And when we run that command, I'll have to scroll back up to actually see the output because I printed it in the console instead of saving it as an object. We can see that R has selected the 3 columns that we provided. And you can select columns in any order. They don't have to be the order that they appear in the data frame. Let me scroll up to the top, and we can see that they are selected in the order that we requested them in. A few weeks ago, we saw how to subset data frames using the bracket notation. dplyr has a useful function called filter. And if you see in the yellow box, the first argument that it expects is the data. So let's continue subsetting on our surveys object. And let's say we want to filter our surveys object or data frame for all rows where species ID equals DS, this code. And it returns all the observations for this particular species. It's a little easier to use. I think it's more direct than using the bracket notation, because with brackets you have to know the index, so the position of the column, whereas with filter you can call them directly. You can call the column directly. Another useful function in the dplyr package is mutate. Mutate allows you to add new columns to an existing data frame using this mutate. So it allows you to add new columns with calculated values. Let's see an example of that. Notice the first argument again is the data you're interested in. In this case, it's surveys. And let's create a new column. It expects that the variables that you provide in these subsequent arguments are new column names, so new variable names, and we want to set this new variable name called hindfoot length in centimeters equal to an existing column, which is hindfoot length, hindfoot, let me see the name, hindfoot length by itself, hindfoot underscore length divided by 10, because we know from the metadata that this was recorded in millimeters. So we want it in centimeters instead. I'll go ahead and run this, and I'll scroll up here so we can see that this new column was added to the end of the table with our calculated values. So that's pretty nifty. In a single line of code, we could do this calculation. And instead of printing them to the console, if we wanted to store them for later use, we would need to assign them to a variable. So for example, maybe I wanted to use this and store it as surveys plus, right? Surveys plus this new column. And if we look at surveys plus, and I'll double click it so you can view it here, it's a data frame with this additional column. If we didn't want to use this intermediate project, we could overwrite the existing variable if we don't need it. We could overwrite surveys, but be aware there is a danger that you overwrite something and you make a mistake, and then you have to go all the way back to the beginning to re-import a fresh data and do all the steps that you got there before you made the mistake. So you can overwrite if you're absolutely sure that what you're overwriting it with is what you want. So I'll go ahead and overwrite, and now our surveys was updated. Another strength of using dplyr functions is that it makes it really easy to aggregate your data. Aggregation combines rows into groups based on one or more columns, and it calculates combined values for each group. For example, if you wanted the mean of hindfoot length by species or by species and month, maybe body size changes over time. The first thing to do to aggregate rows is to use the group by function. And notice there's a few different arguments here. So the first argument is surveys, and then it expects the groupings. So in this case, let's group by species ID, and we'll run this line. And what's the output is called a tibble. It's a different kind of data frame, and not all functions that work on a data frame work on a tibble, so be aware that there are some differences because it contains this grouping information. Most of the time, you will use this grouped as an intermediate because what you're really interested in is calculating some variable by this group. Let's see an example of that by storing this as an object, and then we'll work with that object instead of calling it to the console. So I'm going to run this so that it's now stored in an object called surveys by species. And now we can use another function called summarize to summarize the surveys by species. And it expects a new variable, so abundance, I'm going to call this abundance, equals some value. And I'm going to use the n function to count the number of individuals with this grouped tibble. And this tibble is grouped by species ID. And if I scroll up, we can see now that the output is our grouping as well as the variable that we calculated. And we call it abundance, so now it appears here. And if you're interested in this n function, remember we can question mark the name of the function, which in this case is a single letter n for count. And n gives the current group size. So it counts the number of rows for each group. In this case, it's the number of individuals for each species. In this example, we used a single column, but you can group by multiple columns. Let's say we want to create a surveys by species by plot grouping. So in this example, we would group by our surveys data frame. And in this case, we will want species ID and plot ID. Sometimes these yellow boxes are helpful, but I could imagine if you're watching this, sometimes they get in the way. So I'll try to be conscious of that. All right, I'll go ahead and run this command, this grouping on 2 columns. And now I want to summarize surveys by species by plot. And I want to calculate the same variable. So I'll give it the same name and use that n function to give me the count of individuals by species by plot. And I'll go ahead and run this. And now I see that my tibble is, I see the 2 groups, species ID, plot ID, and abundance. Instead of this n function, you can use other functions that return a single value from a vector. For example, mean, max, or min. Let's see an example of this for species weight. So I'll create an object, species weight, in which to store the output from this summarize function. I want to summarize by my surveys by species, plot, and I want to create a new variable called average weight, and inside that variable I want to store the mean values of weight. So this will calculate mean weight for each group of species and plot. And because I stored it in an object, it didn't print out here, but I'll copy and paste the object name into the console, and we can see how we have this average weight. Oh, why did we get this NA? This should be familiar. If NAs are being returned when you calculate a function like mean, min, or max, it's because you have NAs in the variable you're interested in. We can fix this using the na.remove argument and setting it to true. So let's go ahead and run this line. And I'll call species weight again. And now we get, we don't get NAs, we get NaN, which stands for not a number. And that's because there must have been weights that weren't recorded. So instead, we would have to use na.omit species weight. And now all those individuals that weren't recorded are removed. and we see the species that have weight recorded. Another feature of dplyr is that it makes it easy to combine different operations. And it does each action in sequential order by eliminating the need for intermediate variables. In the examples this above and from a few weeks ago, we saw how we could run a command, store the output in a variable, then use that variable later in the code. Let's see an example of code where we're producing these intermediate variables. So let's call an object ds_data for this particular species, ds. Let's filter our surveys object for rows where species ID is equal to ds. I'm going to run that using the keyboard shortcuts. Now let's create another object called dsData by year, where we group by our dsData object by year. So now we're going to see, let me copy and paste this here. So you can see that our species ds will be grouped by year. And now let's summarize on that grouped data and call this ds weight by year, because we want to summarize on the weight column. We want to summarize on our ds data by year. And I'm going to create a variable, a column called average weight is equal to the mean of our weight column with na.remove equals true. And I'm going to expand this a little bit and make it easier to read. Notice how when to correct the formatting, I did a hard return here, and R automatically formats the code to make it a little easier to read. Alternatively, you could select your code, go to the code tab, and Control-Shift-A is at least the keyboard shortcut. So it'll automatically reformat your code. All right, so I didn't run this last one, this last line of code. Let's go ahead and do that. And then let's view this in the console. So now we have the average weight for our DS species that we filtered for each year. So maybe we wanted to relate this to precipitation of this year. Maybe if there's more precipitation, there's more of its food resource, and it can, individuals are larger, tend to be larger. This is fine. Remember, there's multiple ways of doing the same thing in R. And one challenge of using these intermediate projects is it kind of makes it difficult to keep track of all your objects, and I'm not very creative when coming up with new object names, and instead a dplyr allows us to skip the naming and creation of intermediate object using pipes. Let's see an example of pipes and compare it to this above code. Creating these intermediate variables can get cumbersome, especially if there are lots of steps. And the pipe, I'll show you the icon for it. The syntax is this %Pacman %, or the greater than symbol. But there's a keyboard shortcut. On Windows, it's Control-Shift-M, and on Macs, it's Command-Shift-M. The pipe takes the output of one command and passes it as the input to the next command. So see how this is DS data is the output of this line, whereas DS data is the input of this line. Let's see an example. If we want to take the mean of a vector, normally, let's create a vector using our C function that we learned about a few weeks ago. And if we wanted to take the mean of that vector, we would call the mean function with the vector as the input. With using pipes, we can be a little more efficient with our code and do this by pipe the vector into the function. So we'll use x, pipe, and into the mean function. So x becomes the first argument in mean, and we don't have to provide any arguments in here to designate the data, because R understands that if there's the pipe, then it's pulling in the data from the line above. If we wanted to add other arguments, let's say there's an NA. Let's create a new vector with an NA value, 3NA. If we wanted to calculate the mean of x, we would have to call x as the first argument and call the na.remove argument, or we could pipe x into the mean function and make sure that we're still calling that na.remove function. Okay. So a little more efficient. And so now let's see how we would do this multi-step process using pipes. So our final product was DS weight by year. So let's recreate this object, and instead of using these intermediate project, I'm going to use this pipes. So I'm going to start with my surveys object. Then I'm going to use the pipe symbol, and I like to think of the pipe symbol as equivalent to then do this. So I'm going to take my surveys, then I want to filter the species ID where it equals to DS. Then I want to group by year. Then I want to summarize a variable called average weight, which equals to the mean of weight. And we know that there's NAs in there, so I want to use the argument na.remove equals true. And I'm going to run this line and look at my DS weight by year object. And now I have the year as well as the average weight. So let's see if I can get this on the same few lines so we can compare the two. The same window so we can compare the two. So I'm going to cut this out so we can view these side by side, and I'll expand this and we can really compare the different steps. So here we have to create all these intermediate projects, whereas here, using the dplyr notation of pipes, we're telling R that the intermediate data for each line should be pulled in from the previous line. So here in our filter, instead of designating the data, R understands that the data is from the previous line, right? And whereas our group by, here we have to tell it that it's the input of group by is the output of the previous line, but using the pipes, dplyr understands that. So in none of these steps do we call the data argument. In this last example, and before I continue, I'm going to paste back my pipe so I have it on file. In the next example, I want to demonstrate how we can filter on multiple conditions. In the above, we were filtering on a single condition, and in computing, we can combine conditions in two ways. We can use and. So I could ask our filter species ID equals DS and another species. I can also tell our filter for this species or another species. And means that all of the conditions must be true. Whereas if I use the or notation, either one of those conditions can be true. We'll do this in dplyr using additional comma separated arguments. Let's start out by calling our filter functions on our surveys object. And let's call species underscore ID equals DS and year is greater than 1999. So this will return all the rows in our surveys data frame where species ID equals DS and year is greater than 1999. And it looks like there were no rows that met this condition that were DS and year greater than 1999. So instead, we can use or. This would be equivalent to using and, okay, and year is greater than 1999. So the comma tells R that both conditions need to be met, so they're equivalent. And instead of the and, if we wanted to ask our filter for rows where species ID equals DS or year is greater than 1999, we would use the vertical line, which is on the same key as the backslash. So say we wanted data on all of the DS species, or let's change this to species ID equals DM, or species ID equals DO. And I'm going to use a hard return to make my code a little easier to read. I could do this here too if I wanted to. So now I'm telling our filter surveys for species ID equals DS or DM or DO. So it's going to return all the rows where any of these conditions are true. And if I scroll up to the species ID column, we see that we've filtered out rows that are DM, DS, DM, and there should be DO in here somewhere too. Instead of filtering on existing columns, you can also filter based on aggregated values like the abundance or the mean values that we created above. Let's create an object called species weights and use our pipes to take surveys, then group by species, then filter N for a number of individuals per species greater than 100, then summarize a new variable called average weight equals mean weight. Remember, we have those NAs, so we need to use the NA.remove argument. And I receive an error, must group by variables found in data column. Species is not found. That's because the column is named species ID, so there is no column called species, and that is the last error of the day. Great. And let's take a look at our species weight. And now we've got our species ID and our average weight. For counts for species that have more than 100 individuals, that was this component here. And if we wanted to get rid of this NA.N, we would need to use we would need to pipe this into an NA.omit. Let's see if that removes those NANs, those not a numbers. So in just a few weeks, we've gone from simple subsetting using the bracket notation to becoming familiar with dplyr's functions like filter and summarize, and how to use these pipes to make your code efficient, easy to read, and eliminates the need to think of creative intermediate objects. Continue working on this week's lab. If you have questions, please post them in our discussion board. Nice job.